Welcome to this lesson. In this video, we are going to be solving questions from Tutor Sheet 3. So Tutor Sheet 3 contains questions on polynomials, quadratic equations, binomial expansions, and partial fractions. Okay, so we're going to solve all these questions one by one that you can see. Solving all these questions that you can see here, please register with us. Okay, you can work where I upload a full video on all these questions so you can access them on our website. Right, so now let's start from question one. So question one, they're saying, consider the polynomial f of x is equals to 2x to the power 3 minus 5x squared minus 23x minus 10. The first question is, find the remainder when f of x is divided by x minus 3. Okay, so by the remainder theorem, the remainder when f of x is divided by x minus 3 is found by f of 3 like that. Okay, so where are we getting this 3? We just equate this factor here. Okay, you equate it to 0, and then you solve for x, we are going to find 3. And then you get this 3, you substitute it into the function. Okay, so that's what will give you the remainder. So this will be f of 3 is equals to, I have 3 to the power 3 minus 5, and then 3 squared minus 23, and then 3, then minus 10. All right, so what are we going to have from here? We're going to have 2 multiplied by 27 minus 5, and then multiplied by 9 minus 23 multiplied by 3, okay, and then minus 10. So now let's multiply here. So it will be 2 multiplied by 27, that will be 54, minus 5 multiplied by 9, that will be 45, then minus 23 multiplied by 3, that will be 69, and then minus 10. Right, so when we add all this, we are going to get minus 70 like this, okay? So it means that minus 70 is our remainder, okay, when we divide this polynomial here with x minus 3. Right, so that was the first part. Let's look at the second part. Right, so on the second part, they're saying show that x plus 2 is a factor of f of x, okay? So by the factor theorem, x plus 2 is a factor, okay, of f of x if f of minus 2 is equals to what? To 0. So where are we getting this minus 2? We equate this factor to 0 like that, and then we solve for x. So we're going to get minus 2 like this. Then we get this minus 2, we substitute it into this equation like that. Okay, so let's do that. So to prove that this is a factor, we're going to find f of minus 2. And if f of minus 2 is equals to 0, then we're going to say, yes, this is a factor. So f of minus 2 is equals to 2 minus 2, and then to the power 3 minus 5 minus 2 to the power 2 minus 23, then minus 2 minus 10. So what are we going to have here? We're going to have 2, then in the bracket, minus 8 minus 5, and then here we're going to get minus 4, then minus 23, and then here minus what? 2, minus what? 10. So it means here we're going to get minus 16 minus, in fact, here when we square here, minus 2, we square it, it's going to give us positive 4. Then this positive 4 and minus 5, it will be 20. Then minus, this minus and this minus is going to give me a positive 46. And then I have minus what? 10. So if you add all these, okay, if you add all these, what you discover is you are just going to end up with the minus, you're going to end up with 0, because this first two minus 16 and minus 20, they're going to give me minus 36. Okay, so they're going to give me minus 36, and then plus 46 minus 10 is going to give me positive 36, and this will just be what? 0. So since our f of minus 2 is 0, we're going to conclude that x plus 2 is indeed a what? A factor. Right, so that is it on the second question. Let us now look at the third one. Okay, so the third one, they are saying, hence factorize fully. Okay, so we already know that x plus 2 is a factor. So we just have to use synthetic division, okay, to simplify this cubic function to become a quadratic equation. And then now we can factorize the quadratic. So we're going to say x plus 2 is equals to 0 simply means x is equals to minus 2. So we are going to do a synthetic division here. So we are going to get all the coefficients from this function. So the first coefficient is 2, then I can see minus 5, and then minus 23, and then I can see minus 10. Okay, and then this here is going to come there. All right, and then from there, I'm going to say here, I'm going to put plus, and then I bring down this 2, and then I'm going to say minus 2 multiplied by 2 is going to give me minus 4. And then here you add minus 5 plus minus 4, you're going to get minus 9. Okay, and then minus 2 multiplied by minus 9, I'm going to get plus 18. Okay, and then minus 23 plus 18 is going to give me minus 5. So minus 2 multiplied by minus 5, I'm going to get positive 10. So minus 10 plus positive 10 is just going to give me what? 0. Okay, so it means that when we divide this polynomial here with x plus 2, what we get or what remains is this part here, which will be in form of a quadratic. Okay, so we are now going to get this part as 2x squared minus 9x and then minus 5. Okay, all right, so it means we have something like this now. Okay, so it means we have something like this. We have that 2x to the power 3 minus 5x squared minus 23x minus 10 is equals to, we have the factor x plus 2. Okay, when we divide this factor into this, we are remaining with 2x squared minus 9x, then minus 5. All right, and then from there, we can factorize the other part, which is just a quadratic, this one here. So we find the product, the factor, and the sum. Okay, so the product is 2 multiplied by minus 5, which is minus 10. The sum is minus 9, so it means the factors will just be minus 9 and 1. So if you multiply them, you get this. If you subtract them or add them, you get this. Okay, so it means this whole polynomial here is going to be equals to x plus 2. And then now we factorize this. So when we factorize that, it will be 2x squared. Okay, and then plus x minus 10x minus 5. Okay, so this will be in brackets like that. So this will be x plus 2. And then here we are going to group them. So this part with this, and then that part with that. So what is common in the first bracket here? The ones I've put in blue. The common thing there will just be x. So I'm going to write x. And then inside what do I remain with? 2x plus 1. And then here, what will be common is the minus 5. And then what will remain will be the 2x plus 1. So that's what we want for what is here and there to be the same. So it means the factor here will just be x plus 2. And then we get x minus 5, okay, x minus 5. And then 2x plus 1. Right, so it means this expression here is the expression where we have factorized this guy here completely. Okay, so we factorize this guy here completely to get this guy here. All right, so that's that on factorizing completely. We can erase this. Okay, so let's write this part here somewhere here. So x plus 2, and then x minus 5, and then 2x plus 1. Right, so that is our quadratic our polynomial in terms of its fully factorized form. So the last question here now, they're saying hence solve 2, and then they say 3 to the power 3t minus 5, and then 3 to the power 2t, and then minus 23. 3 to the power t is equals to 10. So how can we solve this? Okay, we have to use what we got here. Okay, so what we are going to do here, I'm going to write this expression as 3 to the power 3 to the power t, and then the 3 outside, minus 5. Then there to be 3t, and then to the power 2, minus 23. And then this will just be 3t is equals to 10. And then I'm going to say, let x be equals to, okay, let x be equals to 3t. So it means what I'll have is 2x to the power 3 minus 5, minus 5 x. What am I writing now? So minus 5x squared minus 23x is equals to what? 10. So this is what I have. Okay, this is what I do what I have. So what am I going to do with this? I'm just going to say this value, take it to the left. Okay, so if I take this 10 to the left, it's going to become a minus 10, and then is equals to what? 0. So what do we notice? We notice that this function here, okay, is the same original polynomial that we had there. Okay, so when we factorize this polynomial completely, we got this. Okay, we got this. So it means what I have in blue, when we factorize it completely, we are going to get that same thing. Okay, but now we'll equate it to 0. So we'll get x plus 2, x minus 5, and then 2x plus 1 is just going to be equals to what? To 0. And then from here, we can now solve for the value of x. So if I equate this to 0 and solve for x, I'm going to get x is equals to minus 2. If I equate this, I'm going to get x is equals to 5. If I equate this, I'm going to get x is equals to minus 1 over 2. Okay. So now we have the value of the x. So it means we can find the value of the what? Of the t. Okay. So 3 to the power t. Okay, as long as it's an exponent, it will never give you a negative number. So it means that because here we are saying x is equals to this. So if here we get minus 2, which is x is equals to 3t like that, okay, this one here is invalid because any number raised to any power, either it's a negative power or a positive power or 0, it will always give you a non-negative what? Answer. Okay, so this one here we're going to say is invalid, okay, or undefined. I'm going to say this is undefined since, okay, 3 to the power t is always greater than or equals to what? To 0 like that, okay? And then what about this x is equals to 5? Okay, so the x is equals to 5 is going to work. So that one, it means our x is 5 is equals to, okay, is equals to 3t like that. So to find the value of t, we're going to introduce ln here, even there ln. So if we introduce ln there, it means we can drop this power in front like that. Okay, so what we're going to have is ln 5 is equals to t, and then ln what? 3. And then divide both sides, okay, divide both sides by ln of 3. So it means t will just be equals to ln of 5 divided by ln of what? 3. So this one here is our final answer. Right, so that's it for this video. If you'd like to access the full solutions where I'll be solving all these other questions here, okay, you can register in the description, and then you're going to find the video where I'll start from question B all the way up to question 8 there. All right, so thank you so much for watching this video. Until we meet next time, this has been Tutor Poul Solutions, always there for you.